Hello, math students, and welcome to our second video in Module 9, Expressions and Equations. The name of this lesson is Writing Products as Sums and Sums as Products, and this is Lesson 2. Our goal for today we are going to learn how to apply the distributive property and undo the distributive property. Okay, so hopefully you guys have dabbled in the distributive property in the past, which I know you have if you were with me last year. The question that I want you to think about in this lesson is, what number can you multiply by anything, and the answer is the number's opposite? Kind of interesting. What number can you multiply by anything, and the answer is the number's opposite? Okay, hopefully throughout this lesson we'll be able to figure that out. Okay, things to remember. This is a quick review because we have to get your brain focused on what we're supposed to be thinking about. So the quick review says, a sum of money was shared between George and Ben in a ratio of 3 to 4. If the sum of money was $56, how much did George get? You must use the tape diagram to solve. You cannot use an equation. You cannot use a number line. You have to use the tape diagram. So I drew it for you, and I would like you to fill this in. So we have 3 to 4, and the total was 56. So you have to figure out what the value is inside of each tape section, okay? Something to check out, remembering that this is a review. Your job is to figure out what one of them would be. So the question that I want you to look at when we're trying to figure out this whole thing is, what does the rectangle labeled X represent? So that's what you're trying to find. Okay, so let's go back and revisit. I have 3 sections up here and 4 sections down here, and all of them together make $56. So hopefully your memory is waking up and you're saying, oh, well, there's 7 sections in total. Since there are 7 sections in total, I have to take the total amount that it costs and divide it by the number of sections. Not bad, right? So we would take 56 and we would divide it by 7 because there were 7 sections total. Everybody knows that 56 divided by 7 is 8. So the value of X is what? X equals $8. Okay? So if you want to write it in, I know this is 8, 8, 8, 8, 8, 8, 8. Okay? So now the other really cool thing that it says, if the sum of money is 56, how much did George get? Do I really want to know what Ben did? Probably not. I do, however, need to know what is the value of each section, and since I need to know what the value of each section is, I found that it was 8, so then I just wrote it in. And when you write it in, X is the value of 8, so again, that's how we figured that out. Then I can just focus on George. So kiddos, to answer the original question of the quick review, how much money did George get? Well, everybody, how much money did George get? The answer is $24. Okay, so George earned $24. All right, so that wasn't so bad. Kind of a review, I hope. If it's not a review, I'm worried about you. Now, can you represent 3 plus 2 using a tape diagram? 3 plus 2 using a tape diagram. Anybody have any thoughts about 3 plus 2 on a tape? Well, it's pretty simple. It is exactly what it says, because remember, tape diagrams encompass what the whole value means. So what is 3 plus 2? The answer is 5. So if I take 1, 2, 3, and I'm freehanding, and I'm sorry that they're not the same shape and size, however, just work with me, and then I have the 2, then I could say that this right here represents 3, and this right here represents the 2. Does everybody see it? So I have 3 plus 2. And when I get 3 plus 2, I can combine them and I get a total of 5, which is what 3 plus 2 equals. So does everybody see how we can represent that as a tape? Okay, well, now that we know how to do that, I would like you to tell me how to represent X plus 2. Okay, so thinking about the same lines, X plus 2, so we have a tape. The unfortunate thing about this tape is one of them is a variable. So do we know the size of the variable? The answer is no. So what I like to do, since the variable came first, is leave some space, and then I'm going to say, okay, well, this is what 2 looks like. So I know that this is 2. So what does this one have to be? Well, this one has to be x, right? So this value from here to here is x, and now I have x plus 2. And so our total would be whatever x plus 2 makes. So this is how you use a tape diagram to show x plus 2. Okay, so if we know how to do that, our next thing that it's asking us to do is, how would we use a tape diagram to show 3 of 3 plus 2? Oh, okay, well, let's go back and look at how we did 3 plus 2. So here's our 3 plus 2 right here. Okay, so I'm going to draw the tape again, 3 plus 2. So I have 1, 2, 3, and then the 2. Okay, so this is 3. I'm going to do this just to help us a little bit. So this would be the 3, right? And then this would be the 2, because that's what we're looking for. And they're not the same number, so we're going to show it that way. So 3 plus 2. But it says that we have to do it how many times? 3 times. So again, I'm going to draw this and have bump, 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 bump. And then I'm going to go 3 plus 2. Now that's only 2 times. How many times was I supposed to do it? 3 times. So I have to go one more time. Okay, dot, 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 dot. So this one is 3, right? And then this one would be 2. Okay. So how do we use a tape diagram to show the quantity? The quantity is what's inside. The quantity of 3 plus 2 3 times. Okay, 3 times the quantity of 3 plus 2. 3 times the quantity of 3 plus 2. The quantity is the 3 plus 2 3 times. 3 times the quantity of 3 plus 2. So that's what we showed. Okay. Well, now the next thing that it's asking us to do is, how about 3 times the quantity x plus 2? So here's what x plus 2 looks like, remember? And so how many times do we have to do it? 3 again. So we're going to draw this one, and we have the dot, and we remembered that this was x, and this is the 2, and so we have to do that again. So we have the dot, this is x, those are the 2, and then one more time, this is x, and these are the 2, and we did that 3 times. So that shows us what that would look like with a tape diagram. Now, some of you are sitting here going, Mrs. Nelson, I'm so over it. Too bad. You have to do tape diagrams because I'm trying to prove a point. We are proving distributive property right now. So take a look at this. It says, using what you know about area, what would be the area represented by the sections of the tape from above? Okay, well, let's do this one first. Okay, so in this one, looking at area, remember, area is length times width, right? Length times width. So if we're focusing only on the reds, what is the length of the reds? 3. What is the width of it? 3. Okay, so we know that we have the quantity of 3 plus 2 3 times. So you're taking 3, because that's the length, times 3. So on this one, it would be 3 times 3. And then we have to do plus, what is the length this time? 2. How many times? 3 times. So we would put 2 times 3. Do you see what we're doing? Okay, so length was 3, width is 3. So 3 times 3. Length was only 2 times 3, so we have 2 times 3. Does everybody see what we're doing? So now we can finish it, and we get 3 times 3 is 9, right? And then we get plus 2 times 3 is 6, and then when you add those together, you get an area of 15. So 15 units, because we're doing area squared, okay? And then let's check it and see if we're right, and let's just do it mathematically without a tape diagram. What is 3 plus 2? Well, 3 plus 2 equals 5, and then I have to multiply that 3 times, and I get an answer of 15 units squared. So it does work, okay? Using the tape works. Using the area model works, okay? All right, so now what did you do to find the area? What did we do? We did length times width. Let's try it for the other one, okay? Actually, let me double check to make sure. Yeah, so now I would like you, just to check to see if you're following along in the notes, I would like you to do this one the same way I did the 3 plus 2 times quantity of 3. So you're going to do this one. I'm going to check your notes for this one. So that's what I would like you to do. Set it up the same way I did right here, except you're using this quantity right here. Got it? So I'm going to be looking for that in your notes. Okay, so moving on to the next thing that I want to go over with you. So you applied the distributive property just now. Believe it or not, all of this that you just did was called the distributive property. Okay? The distributive property states that you multiply the coefficient by all of the terms of the expression inside the parentheses. Factored form tells you that you need to apply the distributive property. So boys and girls, I need you to pay attention to this. This form right here is called factored form. And the reason why it is called factored form is because you have a factor sitting out here, okay? Standard form is when you apply the distributive property, and it's when you get the answer of applying it. Okay, so let's try it. It says, looking down here, what is the area of the gray section? Well, using what we learned on the other page, length times width, so we'll write that down, length times width equals, for the gray section, 1, 2, 3, 4, 5, 6, 7. 7 is our length, times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and there's supposed to be, did I only do 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Mrs. Nelson, good grief. Now I have to draw it in. I'm embarrassed. I'm so sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so these should also be gray. Pretend they're gray. I'm sorry, I made a mistake. That's my fault. Okay. So again, there's 7 of them times 11. Okay, that's the area of that. So the area of that one would be 77 units squared. Okay, now what is the area of the white section? So again, we're remembering length times width. So the length of this one is 1, 2, 3, 4. So I have 4 times 11. We just counted them, and that gives me 44. And then you say, what is the total area of both sections? Well, again, we're going to use length times width. So now we know the whole length, right, is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times, and we know this is 11 because I had to draw it in, and the answer to that I get to that is 121. Okay, so we have to check something because you learned that what you do is you take length times width. So on this first one, we did 7 times 11 plus 4 times 11. And when we did that, 7 times 11 is 77, plus 4 times 11 is 44. And then if you add those up, 77 plus 44, let's see what we get. 11, regroup the 1, 11, 12. Ta-da! What did we get? The exact same answer, okay? And so, doing this over here, this little answer right here that you got, this is called standard form because you found the answer, and the way that we found the answer was by applying the distributive property. Okay, so you guys just did distributive property, and you changed it from factored form to standard form by using the distributive property. Okay, and we double checked ourselves by trying it with the area model, which really, really is helpful. Okay, so hopefully this is all coming together and it's making sense to you. Okay, so now let's look at the back. It says, use tape diagrams to see what each problem looks like. Okay, so I have x plus y plus x plus y plus x plus y. Okay, well, first thing that I have to ask you is, what is the quantity? We have to draw tapes, it says. So I need to draw this tape, which happens to be x and y. And then I have another one, plus x and y, plus another one, so x plus y. Okay, so how many x's do I see? I actually see 3. How many y's do I see? 3. Oh, well, that's not bad. So I could say that this whole tape right here is that I have 3 x plus y's. Do you agree? Okay, another way, so remember, what form is this called? Factored form. How do I turn it into standard form? Well, I just multiplying it out. How many x's do I see? 1, 2, 3. So I have 3x plus, how many y's do I have? 1, 2, 3. 3 y's. So this is called standard form. Okay. So this is factored form because we pulled the common amount that they both have out. It's called factored form. And then standard form means that you applied the distributive property, and that's what standard form is. Okay? All right, so let's try the next one. So in this one, we have x plus x plus x. Okay, so that's not bad. 3 x's. Dunk, dunk, dunk. So that's in that one. Now we have to do this tape, and we have y plus y plus y. So now let's write what we see. Well, I see 3 x's and I see 3 y's. So I could say 3x plus y, again, because we're adding them right there. So again, this is called what? Factored form, right? And then what do I really have? I actually have 3 x's plus 3 y's. And what is this called again? Standard form. And how did we get to the standard form? By using the distributive property. Okay? Last one that we have to show with the tape diagram. 3 x's plus 3 y's. Okay, so I have 3 x's plus 3 y's. Well, for me, I'm just going to do this. And I'm going to say 1, 2, 3, x, 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 1, 2, 3, y, y, y. And that's the tape. Okay, now look up here. What do you notice about our tapes? If we rearranged these and I put all the x's together, would it look like this? Yes. If we rearranged these and put all the y's together, would it look like this? Well then, because we're adding them, I can make it into one long tape, and wouldn't it look like this? So all 3 of these problems are showing you the exact same thing. They just look different, okay? So that's what is really cool about factored form, is that you can factor it out in many different ways and it just looks different, okay? So the final answer after distributing the coefficient is called standard form, and we talked about that up here. Okay, how do you take standard form and turn it into factored form? Well, you basically do the reverse. So we're starting out with standard form, and to undo the distributive property, that's what we have to do. So the thing that you have to think about to do this is it says, think, what do both terms have in common? What does it mean to factor something out? So the thing I'm going to tell you, when you're undoing the distributive property, to do this, you have to be able to find your GCF, which stands for greatest common factor. So looking at 8 and 4, what is the biggest factor that both of them have in it? The factors of 4 are 1, 2, and 4. The factors of 8 are 1, 2, 4, and 8. So out of those factors, which one is the biggest? The answer is 4. So the GCF for this is 4. So then it says, what do both terms have in common? So if I write it out again, so here's 4. That would be 1, 2 times 2, right? And 4. So these two multiply together to get 4, these two. That's called the rainbow method. Then we have 8, and we have 1, we have 2, we have 4, and we have 8. So this multiplies to this, and this multiplies to this. That's the rainbow method. So now you're looking for the greatest, and the greatest that they share is 4. So that's how we found the GCF. So then it says, what does it mean to factor something out? It means that it becomes your coefficient, the one that sits on the outside of the parentheses. So you take the GCF, pull it out, and when you pull it out, it means you're actually dividing it off of each term. So what is 8 divided by 4? 2x. What is 4 divided by 4? 1. So now you did it backwards. So this is what you started out with. That's called factored form, and you ended with standard. Now you started with standard, and you had to end with factored. So remember, this is standard form. Okay, and this is factored form. So you just did it backwards. So in order to be successful with undoing distributive property, how you change standard form into factored form is you have to find the GCF. And I have 3 problems that I want you to try for tomorrow. So 72t plus 8, so find the GCF and then turn it into factored. 36z plus 72, find the GCF and write it in factored. And then 144q minus 60, find the GCF and write it in factored form. And that's what we have. Holy moly, this was a long lesson. We covered a lot. So writing products as sums and sums as products. Products is what we have as the final answer, and then you turn that into sums. So basically standard form into factored form, and then we also did factored form into standard form. Okay, I'll say that again. Standard form turns into factored form, and factored form turns into standard form. So applying the distributive property, unapplying the distributive property. Okay? Today we are going to learn how to apply the distributive property and undo the distributive property. That's exactly what we just did. What number can you multiply by anything? And the answer is its opposite. Think about that, and hopefully you'll be able to come up with the answer. Okay, kiddos? That's all I've got for you today. Talk to you soon.